This question is a tricky question because it requires us to make take a couple pieces of information and put them together. So we see a fish below the surface of water at point P. An observer sees the fish at what depth? Well, what's going to happen is the light from the fish is going to, from this point in the fish, is going to be directed in all directions out. It's going to scatter off the fish and be seen in all directions. But there's going to be a light ray that comes up to the surface, that when it hits the surface, it goes from an index of refraction of approximately equal 1.33 to an index of refraction of 1. It goes from a high index of refraction to low index of refraction. And because of Snell's law, the higher the index of refraction, the lower the angle to keep this value constant. So if I have a high index of refraction and a certain angle, and I go to a low index of refraction, my angle better increase. So my original angle is theta 1. It's this little piece right here. And I'm going to go to a higher angle, theta 2. So that's the light that's going to be refracted into our eyes. It's going to go up to the surface. When it hits the surface, it's going to bend because it goes from a high index of refraction to low index of refraction. It bends to a steeper angle. Well, that's great, except we got to remember that if we're the observer sees light rays and assumes that the light rays come from a straight line. So the observer is going to see this light ray. It's going to see that the fish looks like the fish is at a much higher level than where it originally was at. It sees in a straight line. The person does not know that, or the observer does not know that this light bent. Your brain is not smart enough to detect that. So it's going to see that it's at a shallower depth than really what it's at.